Hello. How are you doing?
Oh, hello, Professor. Oh,
Hi. How are you?
I'm good. How are you?
Good, thank you. Okay, so while we wait, we can check out our notes, syllabus, and assignment for today. And I'll screen share shortly, okay?
Cool.
Yeah, welcome. This is a very large section, so be patient with me. There should be approximately 50 something students or
Okay.
60 something students. So, okay. So if you just got on, log into Canvas. So for every session that I do, I normally go over assignments and lab with the students. So just check out the notes, download that, download your assignments in
Hey, good
Canvas,
job. I'm doing homework.
and work on, check out the syllabus. I'm gonna go over the syllabus shortly, okay?
Okay.
All right. Let me get my Canvas up here. We'll start in a few minutes. Just want to give people a few minutes to get on. Some of the students just exited another class, so. And your assignments and tasks that we're going to be doing is in Unit 1. You will find your notes and your assignments and lab there. Welcome to class. If you just got on, if you just sign in to Zoom and got on now, make sure you check out your assignments notes for this week. You can also look at the syllabus. I'll go over the syllabus in a couple minutes. We'll start at 6. So let me minimize this. Okay, so I think a few more people pop in. My roster show a very large section, so maybe they're gonna get on in a few minutes. Let me open my syllabus. Okay, so we'll go ahead and get started. I think people will trickle in. My name is Casey Nguyen. I am going to be your instructor in assembly programming, which is CIS-11. This class is articulated for Cal State and also UCs. And I teach this class like how Cal State teaches it. We will be using LC3 for ISA. And if you look into LC3, you will find that many universities uses LC3 because it's very close to what you would see with ARM and other assembly language. So in this class, we will learn about your processor that's in your system. And we will talk about different types and how the processor sees data. We will also be programming in assembly, and assembly is a little different than your higher programming language in that you write instructions. So your coding style will be instructions and you will use register. That will be your memory location or what you would see comparable to variables. So low level programming is what we're going to be doing. We are going to talk about how the relationship between hardware and software. This week, we're going to spend a little bit of time touching on number system, because when you use the simulator, you are going to work with hexadecimal and binary because your computer understands everything in binary. So we wanted to see how the computer sees instruction and data, and we are going to map our statements and construct of a regular program to low level. So it is a little different. So be patient and just keep in mind that it is um, a little different than C++, Java, Python that you might have learned in the past. Okay. So we are going to work with computational numerical systems, binary, hexadecimal, and we're going to touch on the conversion of that today. So this class is Zoom schedule meeting. I do require attendance in that. If you miss class, I do have the video for you to watch. However, you can ask questions and get help, or you can come into my office hours to get additional help if you need. We are scheduled for 2 hours. I mostly do lecture for about 11 weeks. I will give you time to do your course project. I am expecting you to write a complete working program by the end of this course in assembly language. So every week we will be working on building assembly programs. So I want to make sure that you understand programming concept and you apply the concept to assembly and be able to produce. So when you leave this class, you should be able to write an assembly program, at least a basic one. So your project requirements, I'll explain that shortly. That's you can work on your project from about week 12 until the end of the semester. Now, the content of this class is being released on Canvas as it is an online class. You will submit your assignments on Canvas along with taking quiz, exam, and complete various tasks. Sometimes we might have some discussion, but we don't always have some discussion. So I try to keep assignments to be about 2 to 3 tasks a week because I understand that you have other class like physics, math, English, and other CIS classes as well. So we are going to learn about processors or microprocessor, and we are going to utilize assembly programming language to program. The way that we can simulate this, and every time that you deal with assembly, you either use a C compiler if it is a type of language that utilize C compiler, or you would use an emulator or a simulator. And in our case, we are going to use an emulator. And for LC3, okay? Now, the construct of the processor really stemmed from von Neumann model. So we will touch on the von Neumann machine, how the processor sees instruction and how it takes your program instructions and break it down into low level, and how it executes. So we are gonna keep things very physical and oriented to the processor when we write assembly. We are going to use LC3 for ASM, and we are going to set up ways to control data along with utilizing loops and control statement in assembly. Okay. We're going to work with instruction formats, and LC3 is one of the better ones to learn as it has a lot less instructions. When you work with ARM or Microsoft ASM, it has a larger set of instructions. Sometimes you have to set flags or do things that's additional. So this is why I choose this language, because it is easier to learn. It allows you to understand the concept compared to Microsoft ASM or ARM. So we are going to work on a numerical data representation today, and we are going to look into how things are pushed onto stack and pop from stack down the line, how to utilize 2's complement to represent sign or negative values, and what the computer see, how the computer see those values. And we will work on data structures, how data is stored on the system, how a group of items can be stored in an array, and how that is broken down at the low level. We are going to look into memory addresses and how that is allocated based on your program, what you instructed to do, and how the programs can be executed with flags and to build applications. So I have taught this class in different type of assembly language, and I found that this particular assembly language is widely taught across university for a reason, right? It is easier for you to learn. So your learning outcome in this class is to be able to analyze, interpret assembly language code, and looking at hexadecimal format, to be able to take a high level program construct and break it down to low level. This is an essential class, especially when you get into the engineering part of the field. So this is important to really grasp, and it really draw in all the pieces in computer science in this particular class. Then you'll be able to write and execute the program in assembly language. Some assembly language, like I said, use compiler. This particular case, we are going to use a simulator. Then we are going to apply mathematical concepts and how that would relate to real world applications or business applications. So advisory for this class is that you should complete CIS-5 because we will touch on programming concepts. And if you haven't, I suggest that you read the textbook. And the textbook is really good at breaking down some of the very easy concept for you, how to create a variable, declare a variable, be able to write your statement in C and correlate from C to assembly. So the knowledge that come into this class, you should have some basic principle and understanding in programming, and also understand how to implement algorithm as procedures for your program. And let's see. So the required materials is this textbook. And if you look at the price for the textbook, it's pricey. I did find a free version for you to download, so you can download the PDF. It is an older textbook, but assembly concept hasn't changed for a long time. Programming concept hasn't changed. There are newer tools and things and libraries that you can implement, but as you know, most of your higher languages are C-based, and C hasn't changed for decades. So just to, going back, I understand that this book is written a while back, but it has useful information, and it utilized LC3. So the author of this book actually created LC3. So I organize everything in modules. So when you look at Canvas, the welcome module has all the information, the resources for the course. So you can look at the resource information. If you need to download the simulator, I'll show you how you can do that. We're going to start with Unit 1 this week. And I make the unit due at the end of the week. So if you have quiz, assignments, lab, it will be due by Sunday. So it gives you some time after class. If you need to go back and watch the video or ask questions, you can and be able to accomplish your task. I do take late work. I don't take it after 3 weeks. As you can see, this course is, that's no problem. Thanks for the notification. This course has a lot of people want to make sure that we are completing tasks on time as developers or engineers. Down the line, you want to make sure that you follow deadline as well. So when it is a week late, it's 10% deducted. 2 weeks late, it's 20% deducted. I do take it beyond the second week. So the third week will be 30% deducted. I don't take it when it's older than that. I will close the assignments a little earlier this semester instead of waiting on the last day. So I want to make sure that we get our assignments in and prepare for the final and our course project. Do you have any question for me? Okay, so we are going to do assignments and lab together. So when you sign on Zoom, you download the assignments or download the lab, and then we'll work on it together. I like to explain the code. I walk the students through the exercises. Some of you have had me before for 7 or other classes. You're familiar with my style, but as some of you are new, So when you come to class, you should always, be prepared. You can read the chapter before, so that way you can ask questions or apply the concept. But we will do the assignments together. Sometimes we will do some, manual coding. Sometimes we will just simply answer questions based on the concept. So your assignments are due at 11:59 on Sunday. There will be a course project, and I will require group work in this case. I found that when I teach assembly, when students work together in groups, they share ideas and they learn from each other. So it is beneficial. I will have a sign up sheet where you can sign up for your groups, and you will work with your group, set up appointments to be able to meet with one another. The maximum size of the group is going to be 4. I will not make any exception beyond that. 4 is a lot. So you can have a group of 4, you can have a group of 2. It's really up to you, but I highly recommend that you work in a group. Okay. Do not wait until the last minute trying to find a group, because you're going to have a hard time looking for someone to work with. So I will release the project about week 9. That's going to give you more than about 7 weeks to set up your project. So now assembly, it normally takes 5 or 6 lines to do a very simple program in C++. It's going to take assembly close to about 40 lines. So the amount of work that you're going to put in for assembly is more. So I just want to make sure that you keep that in mind. Okay. But you can be successful, just divide and conquer. The quizzes, you will have about 3 quizzes, and and I will do like a quiz review game where you have a chance to win a gift card. But it helps you prepare for the quiz. The quizzes are fairly short. They are not lengthy at all, and they usually cover the concept that we touch on in our assignments, lecture, and lab. Quizzes are due at 11:59 on Sunday. And I only give final exam. I do not give midterm. Your project is taking the place of the midterm. So your final exam will be multiple choice, just like the quiz. There will be 50 questions on the final exam. There will be code in some part of the final, and there will be some questions that are relevant to the concept for this class. I don't allow late project or final exam. So it's due on the last day of class. And so if you don't make it on the last day of class, I will not accept it. And that's something that I stick by. It's just fair to all the students that submitted on time or early. And also you cannot turn in late work down the line in your field. Hold on one second. Okay, sorry about that. I just had to turn off the alarm there. So here's your grading category. I follow the standard scale. There's no pluses or minus in your grade. If you get 90 to 100%, that's an A. 80 to 89, that's a B. 70 to 79, that's a C. 60 to 69, that's a D. And 59 and below is an F. For the students that don't participate throughout the course, I can give that student an FW, which slightly change the financial aid status. But if you wish to drop the course, you're going to make sure that you look at the deadline for the course drop. Otherwise, there might be W consequences. So making sure that we understand that. And a lot of W's will impact your financial aid because of the completion rate. So be aware of that and ask financial aid questions if you need to. Your grade categories are quizzes. That will be 10% of your grade. And there will be about 3 quizzes in this class. Assignments and participation will be 35% of your grade. So we will have weekly assignment, and some of your participation will be also accounted for here. Your lab exercises will be 20% of your grade. Your course project will be 15% of your grade. and your exam will be 20% of your grade. So if you decided that you don't want to do the project, it will drop your grade by at least one letter grade, assuming that you got everything completed and full credit on everything else. So for a student that is getting an A and choose not to do the project, possibly the student can be dropped down to a B or below that, and depending on where that student stand with whether it's a high A or a low A. So at least, if it's not running like how you want it to be, you should still submit it. And I will require individual submission for the course project. So I will explain the details when we get closer to the project timeline. Any questions regarding grading? Okay, for student code of conduct, follow the college policy, just to make sure that we are respectful of one another. If you have issues or conflict with someone, just make sure that you bring it to my attention. I hope to be able to help you address it. There is student grievance policy. So in the case that if you need to file a complaint, you can go to the website and there's a form that you can complete that goes to student services, and also sometime in the case of faculty and student, that goes to the academic instructional deans, and then they will address it with you. And if it's involved other people, then they will bring them in to be able to go through the case. Attendance and participation, if the students consistently be absent, I do reserve the right to drop the students. I do have a drop timeline. So if you send me an email asking me to drop you right away, I have to wait for that window to be open in order to drop a student. So if you want to drop, you can drop, but just keep in mind that I'm not allowed to drop student at any time. There's a certain window that I'm able to drop. So the self-elected drop, make sure that we look at our calendar and the timeline, and so that way you don't have any issues down the line. I think we touch a little bit on behavior issues, just to be sensitive to people's feeling, and then especially when you're working in teams or when we have open discussion in the class and whatnot. Now, do not copy and paste people's code. Every semester I scan, and usually I find one or two cases of people submitting work that's from someone else. So make sure that you do your own work. I cover a lot of it in my sessions already. So all you have to do is go through, answer the questions, and submit it. But also when you do the course project, right, do your best, because that's when we're able to assess how you applied the knowledge. So it is subjected to checkers tool. I have various checkers tool that I use, and I read your code. So it takes me a little bit to grade your project, but I do read your code, and I do give you feedback on how you can improve your project for the future. So that's important. Okay. If you need special accommodation like extended test time or anything else, you can contact DSS office. You can visit the office in the library building, room 221, or you can go to the website and you can send them an email or call. Once you submit your request and it's approved, they are going to send me a letter for accessibility accommodation. And based on that letter, I will fulfill that accommodation. So if you need that, make sure that you check that out. For communication, I usually respond to email pretty promptly. I have it on my phone. I check it. The best way that you can reach me is via email or messages, or if you pop into office hours. Okay. But there are downtime sometimes. So I will respond within 24 hours. Even on the weekends. I do stay up pretty late. And so sometimes you catch me and I would respond really late at night, or sometimes I would wait a few hours and respond if I'm tied up teaching or other things. Here are my office hours. So the face-to-face office hours, I am on Zoom when I'm there. I was just there earlier today. So if you can't make it to the campus, you can pop into Zoom. And if you are in the wait room, it's because I have someone else in the office. So just be patient and I'll send you the message. Okay, so that's your Zoom information. And the room that I'm in, it's next to the park, which is PSC 21. It's next to the parking lot. And when you pull in, you just go to the side of the park and then you can park and there and be able to walk up and see me in the office. And if you stop by, I do have snacks and cold drinks. So, you know, and then other faculties are in their offices now too. If you can't make this time, you can also schedule an appointment. I ask that you send me a notification at least a couple hours in advance because I'm teaching 5 classes. So if I'm in class, I can't meet with you, but I can schedule something that would work with your schedule and my schedule. So just drop me in a Canvas message or an email. Okay, any questions? Okay, so that's our syllabus. We are going to come back here real quick and I want to show you something. So the course plan is simply just a planned schedule for our class. It gives you an overview on what you're going to be doing for the whole entire semester. I do change this, so sometimes we might need a little bit more time on a certain lab because we didn't finish. Then I might push back a little bit on the date. Okay, so you can check that out. Also, once you are in the course room, okay, so starting next week, we're going to do assembly. We are going to program in assembly, like hello world in assembly. How is that, right? We're going to talk about instructions and things like that. So LC3 Resources is the page that you can go to. And for those of you who are using Windows PC like I do, you should download the application. So when you click this link, it's going to take you to this page right here. And this is the simulator. And we are going to use a simulator every week for our lab. Okay, so think of it like a way, it's like using your Visual Studio, right? This is a software that we're going to use to be able to program, right? To be able to write our program in LC3 and run it. So this is like your IDE, okay, similar to that. If you have Linux systems, you need to download this file. And so I had downloaded it here, okay? And then you just run the executable. So side note, some of my students from prior semester, when you use anti-malware, sometimes it prevents the application like this to run. So just make sure that you check your configuration on your security software when you install this, because I've had students that try installing it a few times and that they were unsuccessful, and it turns out that it's just the security software that's preventing them from installing. So you can download this if you're using Windows PC. But wait, I know, right? You might be using your MacBook or your iMac. Okay. So there are quite a few people that created LC3 Simulator, and they had released it through the GitHub account. So you can find your simulator. It looks close to what you would see in a regular application. It's just going to be available online. So when you're using Mac OS, or let's say you have Chromebook and you can't install LC3 Simulator, use this, okay? And I will walk you through on how to be able to run your program. So when you write your program, you can write any program in text editor. And those of you who took my Java class, you already know, right? An IDE is just an application that has a text editor, right? And in the case of Visual Studio, right, it would have a C compiler with the appropriate packages to be able to build the program for you. So in this case, what we would do is we would write our code, right? You can use your Notepad++, Sublime Text Editor. There are tons of different type of application that you can use. You can use TextEdit. I think that comes with Mac OS out of the box. You can also use Nano in command line if you like that. All you have to do is save it as the program file, like .asm, to be able to make it in an assembly program, or .java for Java, right? But in our case, we are going to save it as a .asm file, and we're going to run it, using the simulator. Okay. All right. Any question? So this page is LC3 Resources. There are a couple tutorial videos that other universities have done, and LC3 is taught at University of Texas. They teach this at Penn State, Stanford, etc. So this is a commonly learned language, okay, for assembly. Okay, and then there's a website that you can go to, and it kind of walk you through on how to use assembly. We'll touch a little bit on how to be able to look at instructions and then plug in the values and check it, at low level. So I'll walk you through that, but you can check that out. Okay. Any questions? All right. So that's some resources you can see. And then if you don't have Microsoft Office or Office 365, you can download it as you are a student, and you would have the license for the time that you are attending the college. I use Microsoft Word and for most of my assignments, because it's easiest to handle accessibility with Canvas. So now if you are using a Mac OS, and when you're turning in your assignments, make sure that you convert it to PDF for me. I cannot see your dot pages. Okay, I have some students that turn in dot pages, and then I have to give you a 0 and you have to resubmit again. So it will be taking up more of your time. So make sure that you either send me a .docx or a .pdf. That's all I ask for the assignments. Okay. Any questions? Okay, you can post your questions here. This is just an open discussion thread in the case if you're stuck on something. Other students can see this, but if you want my immediate attention or send a private question, just send me an email or a Canvas message. Okay, but I do occasionally check this, and I do post stuff. Or if I get a common questions that are coming through email, like 5 students ask the same questions, I will post that in here, and I will post my response to that, so that way everybody can see and be able to apply it. Okay. And then I will share with you announcements that will be, your task, or sometimes it will be related to scholarship. I do have a grant that's going on where you can get some free money, or fellowship or internships, etc. So I will send some announcement regarding outside of, additional stuff that will benefit you. Okay. All right. So now let's get started with our lessons for today. Any questions regarding class policy and procedures? All right. So as you can see that I have some resources for ARM, and when you are looking to become a developer, right? An ARM developer, you see that there are quite a few jobs for it. You would see the ARM 64 is the current, but there are many different versions of ARM. There are great tutorials online, so there are some resources for you to check out if you plan to do that. So applying this knowledge, you can look into assembly programming as part of your job, or in some cases, you look at some job description and you can take a look at how that can be applied. Now, some developer would choose to do assembly to work with, using to work with processor for low-level programming, or they can also work for to build like browser applications, things like you would see with Chrome, Firefox, and so on. And other cases, they also use it to do libraries. Most of the more modern assembly language, like ARM64, uses C compiler. So you can definitely use your Visual Studio to be able to build your program in ARM, very similar to Microsoft ASM. Okay. All right. So for today, we are going to use our notes. You can find your notes here. And we will start with the first file, which is binary and hex. And for those of you who took my CIS-7, this is review for you, but I added some components to this assignment that's a little different than your CIS-7, so you can follow along. I also uploaded publisher PowerPoint, which occasionally I go over, but not always, and then additional notes that will be relevant to what we're learning in this class. Okay, so I'll cover that. All right, so let's start with our notes. So this week for our Tuesday and Thursday, we are going to cover decimal number system. Okay, decimal, hexadecimal, octal, binary. And for decimal, which is our base 10 number, this is what you've learned since you learned to count when you were younger, right? This is what we learned in our calculus class, which is our base 10 number. And base 10 number needs to be converted to the binary for the system to understand. So when you type into your calculator a number, let's say 4,000, your computer actually converts that to 0 and 1s, which is a base 2 system. Okay. Now, when you're working with our number system, whether it's hexadecimal or decimal or binary, the right digit is always going to be the least significant digit. Okay, so when I refer to the least significant bit or the least significant digit, it's going to be the rightmost digit. Then as we move left, we are going to see that it's going to be more significant. It's higher in significant. So when you're looking at this value, 4,532, which is a decimal value of base 10, right? We would see that the 4 here has the most significant. Okay, so just keep that in mind. Any question? So as we transition from decimal to binary, we know that binary is a base 2. And from a circuit level, it tells you here that the digital circuits, because your computer is an electronic or an electrical machine, right? Your digital circuit processes the signal in 2 level. So when it sees a 0, which is what we refer to as off, right? Your signal will drop. So when we would go from a 5 volts, which is a 1, and it's going to lower it to 0. Let's say we go from a 1 to a 0, it's going to drop the voltage to close to 0. Okay, sometimes not exact. And so that's how it's able to handle your data. So when you play your game, right, all it is just digital circuits that's processing the signal to be able to give you the image that you see, right? All the characters, the weapons, all of these things that you see on screen is then really all it is in the back is just a process signal at the digital level. Okay, any question? All right, so here it touches on how we would see your values, your logic 1 and your logic 0. Now let's say that we need to convert this, okay? So here what we would see is we would have an example of how a binary representation would be. And we always want to use a byte, right, to represent the 8 bits, okay? So when you write out your binary, usually we would chunk it into 8 bits. There are 8 digits. So in this one, 2, 4, 6, 7, it's missing 1. So we automatically assume that the front of this value is going to be a 0. And this little number 2 here indicates that it is a binary number. Okay. So just like your decimal number, the rightmost digit is the least significant and the leftmost digit is the most significant. Okay. Any question? So then what we would have is we would have a value in decimal and its representation in binary. And eventually we'll touch on hexadecimal. Now, the easiest conversion method that I found is going to be adding and subtraction, right? And addition and subtraction is going to allow you to convert between decimal to binary, okay? So now what I like to do is let's go down to here first. So when you convert a decimal value to a binary, we are going to use subtraction method, or you can also use division, but we are going to cover subtraction now. So in this example, you're given a base 10 value, which is 14. And you want to make this 14 into 0 and 1s or binary. So what we're going to do is we are going to look at the scale in the placeholder here. And this scale is always going to be the same exact thing every single time. It is multiple of 2 because binary is, there are only 2 numbers in the binary. So the least significant bit on the right is always going to be equivalent to decimal 1 if it's on. Because 2 to the 0 is equal to 1, 2 to the first is 2, and so on. So as we move left, we raise the power, we increment the power by 1. So as you move left, right, you are going to keep multiply it by 1 from the previous value. So if you forget the scale, you always think about the rightmost least significant digit is going to start with 1. You take that 1, you multiply it by 2, you get a 2. 2 times 2 is 4. 4 times 2 is 8, and so on. And as we go bigger, right, after 256 is a 512, 1028, and so on. So in a byte, the scale is always going to be the same. So now we have a number 14. And we want to make this into a binary. So on this scale, what you want to do is you want to look for the value that you can subtract 14 with. Okay. I cannot subtract 16 because it's higher than 14. So I have to start at number 8. Okay. This is the bit. So when you subtract that, you're going to put a 1 at the top. So at that bit, right, it's going to receive the 5 volt. It's going to turn on the 1. Okay. So I take 14, subtract 8, which is the decimal equivalence. I get a 6. I still have some left over. I take the 6 and then I subtract the next number, which is 4, right? And that's going to give me a 2 left. So as I subtract 4, I put a 1 at the top. So after I subtract 4, I still have a 2 left over. Then the next number I can subtract on this scale is going to be a 2. 2 subtract 2, I have a 0. So your objective is to subtract based on the scale until you have nothing left. Okay. So since I subtract 2 and I have nothing left at the right bit, that one is off, right? I can't subtract it. I didn't subtract it, so I put a 0. Okay. So when we write it out, this 14 base 10 number is going to be equivalent to, oops, it's going to be equivalent to 1110. And in the front, because this is only 4-bit, we can fill in the 4 bits in the front as it will be off. And this is going to give you a byte equivalent of 14. Any question? All right, let's do the first exercise, okay? Let me close my add code file here so I don't. Okay, let's do assignment 1, number 1A. So we are going to use the subtraction method and we are going to convert a base 10 number 149 to binary. Okay, so on this scale, what's the largest number that I can subtract? This, right?
128, yeah.
Yes, so 128. So I would write that down. You don't have to write down all the steps, but I wanted to do it for you so you can see. Okay, so as you subtract that number, don't forget to put a 1 at the top.
Okay.
Okay, so now I'm left with 21, correct? Now, in the next step, I'm going to ask myself, on this scale, what's the next number I can subtract? 16, right? So as you subtract that number, you put a 1 and you would fill in the 0 for all the numbers that you did not subtract. So 21 minus 16.
Okay.
And I have 5 left. So 5 is smaller than 8, so I cannot subtract that. I put a 0. But 5, I can subtract 4. So take 5 minus 4, which gives me a 1 left. So as I subtract 4, I put a 1 there. And 1 is smaller than 2, so I cannot subtract 2. So I put a 0. And then lastly, we have the 1 subtract 1, right? That gives us nothing left. And so really your answer 149 base 10 is going to be equal to 1, 0. We put that over here so we can rewrite it, right? 0, 1, 0, 1, 0, 1. Okay. And if you want to be exact, we would put a base 2 to indicate that it is a binary value. But most of the time when people see 1 and 0, they already know that it's a binary. Okay, that's how you find the answer.
Wow.
Question. All right. So
I guess practice makes perfect for this.
Yeah, it does take a little practice. So, all right, I will help you with B because we just did 1, right? I'm gonna help you do B, but you're gonna have to do C on your own. Okay. All right. So let's look at this. Similar to the same technique, right? This scale doesn't change. It's the same every time. So as long as we're going from convert binary and decimal, it's the same scale. Okay, 307 is a base 10 number. So we are going to, when you go from decimal to binary, you subtract. Okay. So we are going to start with 307 and I'm going to subtract 256 because that's the largest number I can subtract. Now, beyond that, above that, to the left of it is going to be 512. It's going to be too large, so we can't subtract 512. So 307 minus 256. So that's 1, let's see, 51 I'm left with, right?
Yes.
Okay, so as you subtract it, don't forget to put the 1 at the top. Okay, so I subtract this value. And then 51, I cannot subtract 128, so I fill in the 0. Again, I cannot subtract 64 because 51 is smaller, so 0. Then the next number I can subtract with is 32. So we would do 51 minus 32, right? So as you subtract 32, you're going to put a 1. And I'm just going to highlight it so you can see which bit is on. You don't need to do that. Okay, so 51 goes into 32. What is it? 29?
19.
Right? 19, I'm sorry. Yeah. So 19 subtract 16, right? So 19 minus 16 gives you 3. And so since 3 is less than 8, we are going to put a 0 there. And again, it is less than 4. We're going to put the 0 on the next one. And then 3, we can subtract 2. So -2 equal 1. So as we subtract 2, we put a 1. And then lastly, we have 1 minus 1 is going to be a 0. So there,
5, 6, 7, 8, 9.
right? So easy.
Yeah.
So once you get a hang of it, you're like, oh, and then when you do it enough, sometimes you can actually do this all in your head, right? So I want to point out something for you. When you look at the odd number, this bit is always on, right? Because it's a 1. When you deal with an even number, it's always going to be off, the least significant bit. Okay. So that's, and then this is, I found this to be the simplest way to explain to students so they can grasp it, but I'm going to show you another technique on how you can convert. All right, so work on C on your own. It's a small number, so it's really easy. And it's an even number. So 48, convert that to 0 and 1s. And we can do the same, use the same method. So when we write out the answer for B, we can say 307 base 10 is equal to, and then we put 1 0 0 1 1 0 0 1. And if you want to put the base 2, you can put the base 2 like that.
I'm gonna add 16.
Question. All right. So do C for number 1.
Okay.
It's binary.
What
That's
does the
just
base 2 mean? Yeah, it is base 2 represents binary number system. Okay. And that's what the computer stores, right? That's what the computer sees. Whether it's text, numbers, okay, then it's all going to convert it all to binary.
Okay.
All right. Okay, so let's go in reverse. You're welcome. Go in reverse now, okay? So you can work on C. I'm going to explain number 2. And in your notes, it also touches on the addition. Okay, so earlier, just now, we did subtraction when we go from decimal to binary. We are going to use the opposite method, which is addition, to go from binary to decimal. Okay. So the example here, it tells you that this is a binary that you are given. So just like, so we're working backwards now, right? So just like what you've done, right? You're going to take this binary, you're going to put it on top of your scale. And I always start with the right digit. So that way, that's how the computer sees it, from right to left, right? It's going to be the least significant bit. So put the 0, the 1s on top of your scale, your placeholder. And as you do so, you are going to notice that certain bits are on, right? Like this one, and this one, and this one, and this one, right?
Right.
So that means that we're going to take these values and we're going to add them up. So you're only going to add the values that have the 1 on the top or when that bit is on. Okay. So that's why we're adding 32 plus 16 plus 4 plus 2, because at that bit, those bits, they have 1s, and that's how we would be able to know that we would be able to convert it back to a decimal. So once you add it up, you're going to get a 54 here, and that's your decimal value. Okay. All right, let's work on the next one, which is D. Okay, really easy, right? We are going to take this binary value. We're going to put it on top of our scale. 1, 0, 1, 1, 1, 0, and 1, right? And then if you want, you can put a 0 in front of it. Assume, right? We always assume that there's a 0 in the front. So I'm going to double check and make sure that everything is correct. Okay. And then just like what we just covered right now, we are going to only add up the value that has the ones on the top. And I highlight it for you so you can see, but you don't need to do that. Okay. So we are going to take 128. We are going to plus it with 32. We're going to plus it with 16. We're going to plus it with 4. And we're going to plus it with 1. So 20, 52, 53.
I think you forgot the 8.
Oh, yeah.
That's 8.
Thank you. I'm ahead of myself there. Plus 8. Thank you. All right. That's good now. So what, 20, 21, 29. And if you want, you can take out your calculator so you don't make the mistake. And I'm going to show you how you can use your programmer calculator. So 128 plus 32 plus 16 plus 8 plus 4 plus 1, right? I got 189.
Four.
Check, right?
Right.
All right. Okay. So this is good and dandy, right? We want to know the concept on how to do this manually because it's important that you understand the very basic level of what the computer does. And that's important in this field, right? Even if you program, you wanted to know how the computer sees your data. But practice-wise, we're not going to have time to sit through and do this. So you do have a programmer mode on your calculator. And I'm using Windows PC. So when you open up your calculator, there are different modes here, right? For example, you can use scientific mode, graphing, and so on, right? For other classes. But for our class, you can also use your programmer calculator to check.
Okay.
So let's check our answer now, right? I have this value. I'll copy this. And as it is in binary, I select bin for binary. Okay. And to find the answer, I click decimal. So to see, it shows me 189. So we are correct. And as you see in the calculator, it shows you what that will be in hexadecimal. That's what we're going to talk about. And then what will be in octal, right? And then binary is this.
Cool.
Okay. Now, when you use your calculator, when we start working with a larger value or negative value, you're going to notice that it's going to put in a lot of different zeros and ones in the front too, right? So I want you to pay attention to this button right here. This is what you would tell the system to be a word size. Is there a programmer? I think, I don't know if there's a mode for it, but I think you can download an app on the iOS, that the programmer calculator on iOS from what the students, they told me before. Oh, you found it? Okay, good. Yeah. You just search for it. Everything's searchable anyway. All right. So here, what you would see is this indicate your how many words that would be right in for that system. So when it shows you keyword right here, that means that it is a quad word. And by standard, a lot of the system, depending on the processor, many processor use 16-bit is equivalent to 1 word. And you're going to need to know that for your final and quizzes. 16 bits is going to be equal to a word. So we know that 8 bits is a byte, right? And 16 bits is a word. So if it's a quad word, what does that mean? It's 4 times 16 bits, which gives you 64. So if I make it a double word, right, is 16 bits plus 16 bits, or 16 bits times 2, that is 32 bits. Okay, so this allows us to control how our answer is going to be displayed, whether you want it in 4 words or 2 words or 1 word or a byte. In some cases, we're going to have a long binary where we need to make sure that it's going to fit in that storage location. So when we say word, all that is 16 bits, and 16 bits just represents, right, that size of your data in the system. Question. Okay, so as we already practiced with D, I want you to do E and F on your own. Okay. So put the binary on top, add the ones that have the ones or the bits that are on, and then write down the answer. So the base just tells you what number system that we're using. That's all. Okay.
Okay.
So make sure that you know how to do this, because you are expected to know how to do this for your quiz and exam. Okay. And for the tests, there is no programmer calculator. There's only scientific calculator that I enable on lockdown browsers. So make sure that we know how to do it. And you can use scrap paper and so on as you take the test on Canvas. But all right. So the rest of these is the same as D. Okay. Any question? I'll help you with G since some of you are working on it now. So G isn't a small one. So 0. Actually, I'll do this from the right. 0, 1, 1, 0, 1. And we would assume that the front will also be 0, right? So I want to check and make sure my digits are correct. So this one is 4 plus, let's do 16 plus 4 plus 2 equal to 22, right?
Six.
Okay. All right, next we are going to cover addition in binary. So how does a computer handle addition? So first, when you punch things into the calculator like 2 plus 2, right, you would get a 4 as a result. The computer takes your value that you entered to convert it to binary, and then the next input convert it to binary, and then operate addition. So the rules of additions are, when you take a 0, you add it with the 0, you get a 0. when you take a 1, you add it with the 0, you get a 1. And keep in mind that these are in binary. Okay, so 1 plus a 0 is a 1. A 0 plus a 1 is a 1. But when you do a 1 plus a 1, it's a 0 with a carry over to the left. Just like how you take, let's say, a 1 plus a 9, right? You get a 0 with a carry 1. It's similar to that. You're going to carry that 1 to the left column. Okay. All right, let's practice. So here is an example. You have this value on the top, which is 4, right? In decimal, and this is the binary. And then the second value, which is 7 in decimal, and this is the binary. So we know in our mind that 4 plus 7 should give you 11, but we wanted to add this in binary and see if it's going to come out to be 11. Okay. So going back to the rules, a 0 plus a 1 is going to give you a 1. A 0 plus a 1 is going to output 1. A 1 plus a 1 is a 0, and we're going to carry that 1 to the left column. Now, I want you to note that when you do addition and subtraction and multiplication in binary, handle 2 numbers at a time. Okay, so when you do that 1, when you do a carry, you're going to do a 1 plus a 0 is going to be a 1 here. You're going to take that 1 and then you're going to add it with this. A 1 plus a 0 is going to give you a 1. And then since we don't have any extra carry that trickle from the right, we would just take the 0 down, because 0 plus a 0 is a 0. 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 So our output is 11, right? 1 plus 2 plus 8 is 11. Question. All right, let's do H together. And I'm going to use my whiteboard, okay? And sorry about my chicken scratch. That's why I type instead of write. But all right, so here is question H. And if you want to, you can, handwrite things on your assignments and scan it, take a picture of it. You can turn it in that way. I'll take assignments. It doesn't have to be completely typed, but if you want to type it and make it nice and neat, that's great too. Okay, so just like what we've learned right now, let me move some of these bars. That's the best we're going to do with Zoom. Okay, so we're going to start from the right. We're going to add. So we're going to start with this one. Okay, a 1 plus a 0 is going to give you a 1. A 0 plus a 1 is going to give you a 1. A 1 plus a 1 is going to give you a 0 with the carry 1. Now, just like what I said before, we are going to, I'm going to switch pen real quick. Sorry, it just, things are. Let me switch pen. So you are going to handle 2 numbers at a time. Okay. So we're going to take care of the carry with the top value and we're going to add it. So a 1 plus a 1, you get a 0 with a carry 1. Now we have a 0 from the result of the carry and the top number. We're going to add this two together, which gives us a 0. Now moving to the next column, since we have the carry from the last round, we're going to take the 1 plus a 0 first, right? That's going to give us a 1. Then we're going to take that 1 and plus it with the 1. We're going to get a 0 with the carry. That's correct. And then now we are going to do again with these two, right? So a 1 plus a 1 is a 0 with the carry 1. A 0 with the 1 is a 1. Now handle the carry with the top. A 1 plus a 0 is a 1. A 1 plus a 1 is a 0 with the carry 1.
Okay.
A 1 plus a 1 is a 0 with the carry 1.
Right.
A 0 plus a 1 is a 1. So assume that this is a 0 right here, right? Because there's
Right.
nothing there, so it's off. 1 plus a 0 is a 1. That's your answer. Easy, right?
Yeah, we have 9 digits. Does that matter?
Yeah, it's fine. So that means that here is a byte and it's going to flow into the next byte, right?
Okay.
And sometime you have more, sometime you have 20 digits. So it's just larger data. Right? So when you're saving a file and it tells you, let's say your file is, I don't know, 12 kilobytes, right? So all of the 0 and 1s take up that storage. Question. So as you learn how to do H, anybody wants me to go over this again? Are we okay?
Yes, please.
Okay, let's do it again. Okay, one more time. Let me clear. Let me Control Z so I don't have to rewrite real quick. Okay, there we go. All right, going from right to left, right? A 1 plus a 0 is a 1. That's easy. A 0 with the 1 plus a 1 is a 1. Now, when we get to the 1 and 1, we're going to carry. So a 1 plus a 1 is a 0 with the carry. So when you see a carry, you want to make sure that you handle the carry with the top number first. So I add these two, I'm going to get a 0 from that result. Okay, but I have a carry. So a 1 plus a 1 is a 0 with the carry. Now I'm going to add this next. So a 0 plus a 0 is a 0, right? Now we're going to handle again the carry with the top number. So a 1 plus a 0 is a 1. A 1 plus a 1, we're going to do the bottom now. A 1 plus a 1 is a 0 with the carry. And again, repeat. We're going to handle the top. 1 plus a 1 is a 0 with the carry. A 0 plus a 1 is a 1. A 1 plus a 0 is a 1. 1, now we're going to do this part. So a 1 plus a 1 is a 0 with the carry. A 1 plus a 1 is a 0 with the carry. Now take care of this. 0 with the 1 is a 1. Now that 1 is hanging in the front because it flows into the next byte. So there's an extra bit there, right? So we assume that we would have 0 right here, right? So 1 plus a 0 is a 1. Because if it's empty, it's off. And so there you go. Questions? All right, good. So make sure we know how to do addition. And you can try I on your own. This one has some carries, so it gives you good practice. Okay. So you will see questions like this on the quiz and the exam, where it would ask you to convert binary to decimal, decimal to binary, do some addition. The reason why we're doing this is when you use the simulator, right, there will be time that you need to check your value in hexadecimal or look at the binary equivalent to really see if where your area, your data actually goes. Okay, which register, which location, and so on. I have this recorded, so I will put the video up tonight after the class ends. So if you need to watch it again to practice, you can. All right, let's touch on hexadecimal now. So hexadecimal is another number system, and some of you have used hex before or have seen it before. Okay. When you program HTML, you sometimes use color or color wheel, okay, to, code your website. And so you would use the hex color value to be able to change something from, let's say, white to red or yellow. We also see hexadecimal in different type of system addresses. The reason why that we transition to a certain number system is because it gives us more probability in utilizing that number. So when you're going from a base 10 to a base 16, you have more variation in the numbers on how it's used. So now we are going to learn hexadecimal. And hexadecimal, okay, when you, let me go back to the notes to see if I actually have that written for you already. Give me 1 second. Let me close this. Actually, let me cover the division method so you know how to do this, because I know some of you are interested in learning this real quick. Okay, so in the notes, I added the division method. Let me clear Canvas here, and I wanted to write this out. So when you change when you convert decimal to binary, you can subtract or you can divide. The way that you use division is you are still going to have to divide it by 2 because it's a 2 number system. And so when you convert a value like 152, you simply take that 152 and you divide it by 2, just like how we would go down that line and we would subtract it. And when you have a remainder, then at that bit it's on. So in this case, if we take 152 divided by 2, we have 76 as a quotient. And since there's nothing that's remained, you put a 0, it's off. And then you have a quotient of 76 that's left. You take that again and you divide it by 2 again, just like how we continue to subtract. So 76 divided by 2, you have 38 with no remainder. So put a 0 for the remainder. Then take 38 divided by 2, you get a 19 with no remainder. So if there's no remainder, you put a 0. Now here we have 19 divided by 2. 19 goes into 2, right? 9 times. So 9 as a quotient with 1 remainder. Because it's an odd number, you're going to have 1 as a remainder. So if it has a remainder, you put a 1. Okay? Then again, you are going to take 9 divided by 2. Since that's also have a remainder, you put a 1. So 4 is a quotient with 1 remainder. Then 4 divided by 2, you get 2 as a quotient with 0 remainder, 0. 2 divided by 2, because we have 2 left here, is 1 time, and that's going to give us no remainder. But wait, we're not done, right? You still have that 1. Just like how we have to subtract until we get to 0, here you have to divide until you get to 0. So 1 divided by 2, you get a 0 as a quotient with 1 remainder. Okay. So as you write this down, this is your binary value. See how I highlighted it? So the leftmost digit is at the bottom. So you're going to write bottom up, left to right. Okay. And that's how you can derive. So either way, you can choose to subtract or you can choose to divide. But as you pay attention to this, you notice that it is almost the same thing, right? You subtract until you can't anymore, and it is divisible by 2 because it's a base 2. So with that, we can say that when you subtract, when you divide, you just subtract multiple times. Okay. When you multiply, you add multiple times. The computer only adds. And we will see why. Okay, so we already touched on addition. Okay. Let me see. Since we are, I'm going to cover this and then I'm going to come back to binary subtraction. Actually, yeah, let me do binary subtraction. I'm sorry. So that way you can understand a little bit more. Let's learn how to subtract and multiply in binary. All right, so we already learned addition just now. Here is subtraction. Same rule, okay? When you take 0, subtract 0, you get a 0. When you take a 1, subtract a 0, you get a 1. When you take a 1, subtract a 1, you get a 0. When you take a 0, subtract a 1, just like how you do in decimal number, you are going to get a 1, but you're going to borrow from the left side. Just like how we take a 2, subtract a 3, right? It goes into the negative number, but in binary, there's no negative binary. There will just be a 1, but we're going to borrow from the left side. So just like how you do the carry. Okay. So here, what we would have is we have this binary. Okay, 1 0 1 0 1, and then subtract this binary 1 0 1 1 1. So you take a 1, you subtract a 1, you get a 0. You take a 0, you subtract a 1, you get a 1 with the borrow. Okay. And then you are going to handle the top just like before. Okay, so the way that they write this is they treat it like a 1 and a 0, and then you would handle it 2 number at a time. Okay, so this might look confusing because they've written it out this way, but let's try it here. Okay, so let's do a value. Let's say we're going to do a 1, a 0, a 1, a 0, a 1. And then we're going to subtract it with 0, a 1, a 0, a 1, and a 1. So on the decimal equivalents, this is 1, 4, 16, right? 16, 4, 21 on the top. Somebody check my math. 1, 2, 4, 8, 16, 16, 4, 1. Yep. And then on the bottom, you have 2, right? 8, which is 10, and then 16, which is 26. Okay. So we can check our answer. Okay. So we're going to take a 1 minus a 0. You get, going back here, right? I'm going to scroll up so you can see the rule, which is a 1. A 0 minus a 1 is going to be a, what is it? A 0 with the borrow. Or I'm sorry, a 1 with the borrow. A 1 with the borrow. Okay. Then you're going to do a 1 minus a 1 is a 0. A 0 minus a 0 is a 0. A 0 minus a 1 is a 1 with the borrow. And just like what we did before, we handle the top 2 and the bottom separately. Okay. So a 1 minus a 1 is going to be a 0. A 0 minus a 1 is a 1 with a borrow. And then this one just drop down. Okay. So this is supposed to be -5, correct? Okay. Now, I'm going to touch on the 2's complement on how -5 is represented, because if you convert this, right, it's actually the 2's complement of 5. Okay. With the +1. So we'll talk about 2's complement shortly. So that's how you do subtraction. Now for multiplication, it's really easy. It's actually very close to our decimal value. The hard part is to do the addition, right, at the end. Okay, so I'm going to walk you through this. Let me clear my canvas here, and then let's do that manually. Okay, so let's do another number. That one is really easy. So the 1, 1, 0, 0, and then we can multiply it by 1, 0, 1, 0, let's say. So the rule for multiplication before we start, 0 times 0 is 0, 0 times 1 is a 0, very similar to decimal. A 0 times a 1 is a 0, and a 1 times a 1 is a 1. Okay, so here, a 0 times a 0, we start with the right is a 0, right? And I'm going to multiply here, and then I'm going to take it and multiply here, and then so on, very much like our decimal number. So a 0 times a 0 is a 0. A 0 times a 1 is a 0. A 0 times a 1 is a 0. So everything is 0 there. Then we move to the next digit. So now we're going to go
1 times a 0.
this way and then this way, right? 1 times a 0 is a 0. 1 times a 0 is 0. 1 times 1 is a 1. 1 times 1 is a 1. Then we are going to go to the next digit, right? So everything else is 0 again. And then we are going to go to the next digit, right? So just like the other one, you are going, so as you move left, you notice that we're moving, we're shifting it, right? Our digit to the left a little bit, just like how you do with the decimal. So now we are going to also have 0, 0, 1, 1. And then you are going to add it and apply addition method here.
Okay.
Okay. So then, right, this 0 would just drop down. These 0 would just drop down. These 0 would just drop down. Now, just like before, we are going to handle 2 numbers at a time. So 0 plus 1 is a 1, right? And again, 1 plus the 0 is a 1. Again, 1 plus 0 is a 1. Then move to the left column, right? Since this is assuming 0 in the front, so we are going to do, we're going to do 1 plus a 0 is a 1. And then handle the bottom with the result right here. 1 plus a 0 is a 1.
Right.
And then here, 1 plus a 0 is a 1. 0 plus a 1 is a 1. Yeah, multiplication is easy once you learn how to add. Okay, so that's, you can refer to the notes for also additional example. Right. Okay, so here it talks about a byte is 8 bits. Okay, and then a word size, and in the architecture we're learning, our word size is 16. Same thing with Microsoft. Okay, so 4 words is going to give you 64-bit. Double words or 2 words is going to give you 32 bits. Okay, and a byte is half of a word, and half of a byte is called a nibble, 4 bits. All right, let's talk about hexadecimal. So hexadecimal, this is the system. Okay. So you're going to have 0 through 9. So when I have a 0 in decimal, that's equivalent to a 0 in hexadecimal. If I have a number 5 in decimal, that will be equivalent to 5 in hexadecimal, and 5 in hexadecimal. And then, so 0 through 9 is the same as decimal. But when you get to 10 in in decimal, that's going to be equivalent to A. Okay, so I'm going to put that here. So 0 through 9, right? Is going to be equivalent to 0 through 9 in hexadecimal. So when you have a decimal that's 10, that's going to be A in hexadecimal. 11 is B. 12 is C. 13 is D. 14 is E. 15 is F, and it stops because there are only 16 numbers in hexadecimal. So this is your equivalent scale on the left, and this is your hexadecimal value on the right. So when I see a C in hexadecimal, I know that is 12 in decimal or base 10. Okay. If I see a number 5, I know that it is same in hexadecimal. But when I see F in hexadecimal, I know that it is 15 in decimal. Okay, so we want to establish that first. Any question? All right. Now let's take a look at the assignment as we want to address this. So here I put down the step for you. When we convert hexadecimal to binary, because hexadecimal represent the value can be represented. Each of the digit in hexadecimal can be represented into 4 bits, a nibble. So a word is 16 bits, right? That can represent 4 hexadecimal digits. A byte can represent 2, right? It can store 2 hexadecimal digits.
Mhm.
Okay. All right, so let's take a look at this example. This is a hexadecimal value because it is base 16. So you would have 4E, which is hexadecimal, and we want to make this into binary. Okay. So first you're going to take one of the digit, which is 4. Okay. And the hexadecimal, we know that it represents the 4 bits. So what is the 4 equivalents in what is 4 in hexadecimal? What is the decimal value that will be equal to 4 in hexadecimal, which is 4, right? 4 is 4 in both. So
Right.
you simply convert 4 in decimal into binary, which gives you this. 0, off for 1, off for 2, on 4, and off for 8. Then we move over to the next digit, E, and coming back to what we talked about earlier, E is 14 in decimal. So that means that 14 in decimal, we just need to convert that back, that 14 to binary. So what is 14? 2 plus 8 plus 2 plus 8 plus 4, right? So 2 plus 8 plus 4. That's your binary. Okay. All right, let's do this together. I actually wrote it down from the prior semester or last year. So here's your hexadecimal value, 4B1C. And let's just don't think about that now. Okay. So first we are going to take the 4 and we want to convert that 4 into the binary. And that we already saw that in the example. So you got the 1 that's off, 2, the second bit that's off, 4 that's on, right? And then 8 off. So take the 4 and convert it into binary. Treat it like a decimal. Okay. Any question? So let me do that here so you can see. 4B1C. So a 4 is equal to 1, 2, 4, 8, right? This 4 is on and the rest is off. Now we're going to move over to B, and B is 11 in decimal. So 1, 2, 4, 8. So 11. Right?
Right.
And then 1, that's easy. That just means the last bit is on in the 4 bits. So 1, 2, 4, 8, that bit is on. Okay. And then lastly, C is 12. So 1, 2, 4, 8. So what adds up to be 12? These 2, right?
8, 4.
Yep. So when you write it out, here's the 4, right? Here is the B, here is the 1, and here is the C. So it would look something like this. Questions? So this is the binary representation of this hex value, right? If you wanted to add the base, you can. So that way we can distinguish between the number systems. That's okay.
But you know binary when you see it, right?
Yes, that is
Yeah.
correct. So now that one is easy, right? So doesn't matter what number system when you convert from one to the other, and you can do hexadecimal to binary and then binary to decimal. So that's why you see my notes that's here, right? So what happens is when you go from binary to decimal, you would now need to add up all the value that has the ones at the top based on the scale, right? See how I put the note there? So you would just add like the 4 plus the 8 plus the 16, and then going to 256, 512, and then and so on. So it keeps increasing. So you're going to end up, this hexadecimal values is equivalent to a very large decimal value, and you can test it. So let's say we're going to clear this, right? So if our hex is 4B1C,
Have it on byte still.
yeah, that's right. What's with me today? It's getting to dinner time. That's I can't think. Oh, sorry. 1C. Okay. Yeah. So as you can see, your decimal is very large. As we would add up the value that had the ones at the top. So you would notice here that it's 19,228. Okay. So whatever is easier for you, sometimes you can convert it directly from hexadecimal to decimal, or you can convert it to a binary and then convert it again. Whichever that you think is easy. Okay, so next I'm going to show you how you can do directly from hexadecimal to decimal and then go in reverse and then do the addition. And that will hopefully I'll be able to finish. So I do have about 20 minutes left or so, about 20-30 minutes left. So I want to be able to address that. Okay. So before I break down the next question, I want to come back to the notes and so kind of give you the overview first. So the example on page 7 in your notes is gonna be relevant to what we're gonna be learning going from hexadecimal to decimal. Okay. Here's the example. Let's say that I have 3B in hexadecimal, which is a base 16, and I want to make this into a base 10. Okay, so there are 2 digits here, and so what you do is you are going to write out the values, and we are going to start from the right hand side. So we know that B is 11, okay, in decimal. And we are going to multiply 11 by 16 to the 0 power because it's the least significant digit on the right side. So it starts with the 0 power. So anything to the 0 exponent is 1, right?
Right.
So it's like taking 11 times 1. Then after that, we're going to move to the next digit, which is 3. And as you move left, you're going to multiply it by 16 to the power. We're going to increment the power by 1. So here we start with the 0 on the right, and as we move left, we're going to multiply 3 times 16 to the first because it's the next digit from the least significant. Okay, So 3 times 16, that gives you 48. So 48 plus 11, which is 59 base 10. Okay, let's try the next assignment question now. Okay. So I have it written out, but let me explain it. Okay. So first, this is our hexadecimal value that's given to us here. Okay.
Okay.
And what I do is I start with the right because that's the least significant digit. So you take F and remember the scale. F is 15 in decimal. So I take 15, I multiply it by 16 to the 0 power. Okay. That takes care of the F. Then I'm going to add that to the next digit, which is D. So D is 13. So I would take 13 times 16 to the first because it's the next digit to the left of the least significant bit. So we're going to increment the power by 1. So that is for D. Then again, we're going to do B. So B is 11, and we're going to multiply it by 16 to the second because it is the third digit from, or the third digit from the right. So that will be 16 to the second. Plus, and then I get to the 1, and 1 is 1 in decimal. So we would say 1 times 16 to the third because it's 1. We got to increase the exponent now as we move from, B over, right? So then lastly, our 8. So 8 is going to times 16 to the 4th because 8 is 8 in decimal. So, and you can multiply it out, right? So I had 15, then 13 times 16. 13 times 16 equals, so this is going to give me 208. And then you have 16. I should have switched this to scientific. So 16 squared, right, times 11. That's going to give me 2008, 2816. And then the next is going to be 16 to the third. So that's 4096. And then you still have to add them all up together. Okay. You can plug this entire thing into your scientific calculator like this. You can copy and paste it in and then operate it, or you can calculate individually like what I've done. Okay. 16 to the 4th times 8 equals, I'll just copy this. And then you still have to add them up. 15 plus 208 plus 2008-16 plus this, and that's going to give you the output for the decimal. Okay. And then you can use your programmer calculator to check. So if your hex is 81B DF, okay, then your decimal should be that value. All right.
That's good.
Any question? So this is the multiplication method for hexadecimal to decimal conversion. So when we convert, right, when we convert from hexadecimal to decimal, we multiply. When we convert from decimal to hexadecimal, we divide. Okay, so I still have a little bit of time, so let's hit that next. And on your assignment, I gave you an example, and this is helpful if you know how to do long division. Okay. So just like what you've learned in the division method in binary, you are going to divide by, right, that number system, which is 16 for the hexadecimal or 2 for the binary. So here, we're going to take the decimal value that's given to us, and we're going to divide it by 16 until we cannot divide anymore, until we get to 0, right? So the first step in this example is we take this value, which is 61,453, we divide it by 16. And so once you divide, you're going to get a quotient, okay, which is 3840. So when you do the long division, 61 divided by 16, it's 3 times. And then, you know, you have the remainder, you carry that down, you bring down to 4, you divide it by again, you get 8 times, and so on. Now, when you do the division method, the remainder is always of importance, okay? It's actually the answer, okay? So when you take this value, you divide it by 16, you get a quotient and you have a remainder, which is 13. And 13, that translates to D in hexadecimal because we're going from decimal to hexadecimal. So 13 in decimal is equal to D in hexadecimal. Then we're not done. We still have that quotient, and we're going to take that quotient, we're going to divide it by 16 again. So the next step, we're going to get 240 as a quotient with 0 remainder. It divides evenly. And so when you get 0 remainder, you put a 0. Okay. Because the 0 is a 0. A 0 in decimal is a 0 in hexadecimal. Then you have 240 left, and you would take 240 divided by 16. That's going to give you 15 as a quotient with, again, 0 remainder. So 0. Okay. We're not done here because we still have 15. You're going to take 15 divided by 16. You get 0 as a quotient until you get to the 0 quotient. That's when you're done. But you have 15 as a remainder because, you know, 15 is smaller than 16. It's going to remain 15. So 15 as a remainder, and 15 in decimal is equivalent to F in hexadecimal. So the way that you write it out here, right, we're going to combine everything together. It's going to start from bottom left to right. So F00D. Okay. And often you would see it as 0xFOOD. It depends on the system on how they display the hexadecimal value. But we use hex for memory addresses, system addresses, a lot of different things that we use for MAC addresses and so on. So, you know how to read it and convert it is important. All right, let's try the next question. Okay, so we are going to take 168 and we're going to make it into a hexadecimal. We're going to use the division method. Okay, so where's my pen? So here I'm going to start with 168. And we are going to do long division, so 16. So 16 divided by 16 is 1 time, and that divides evenly. So 0, we're going to bring down the 8. 8 divided by 16, 0 time. Okay. So you should have 10 quotient with an 8 remainder. Right?
Right.
Okay. So make a note of this. So I normally put an R8. So I know that because that's part of the answer. Now, since we have 10 as a quotient, we're going to take 10. We're going to divide it by 16 again. That gives you 0 time with 10 as the remainder. So R10. And pay attention to the 10 because 10 in decimal is equivalent to an A, right? In hexadecimal. And an 8 is equal to an 8. So our answer to this would be A8. And let's check. Right? If we have a hex, or I'm sorry, a decimal 168 is equal to A8 in hex. And that's correct. Sorry, my screen is all. Any question? So this requires a little bit of long division knowledge, right? Practice. Because if you haven't done long division for a while, right, you just got to come back to it and learn how to do it again. Okay.
The problem I would have is knowing when to multiply or divide. How do you?
Okay. So pay attention to the question here, right? So when you go from decimal to hexadecimal, you divide. When
Just have
you're
to
going,
remember that.
yeah. So when you're going from hexadecimal to decimal, you multiply because, you know, you are going to increment based on, you know, the 10, 16 to the n power.
Okay.
So when you're going from decimal to hexadecimal, you divide. When you're going from hexadecimal to decimal, you multiply. Mhm.
That's something to think about. You have to think, I guess, remember, huh? Let me write that
Right.
down.
So here, right, on the, yeah, so after practicing a while, you're going to be able to get. So number 4 is a little lengthy, right? You can do that because it's just like this, just a larger number. So you would take, I'll write it out for you a little bit, but I'm not going to solve it for you. So you know how to solve it. 60293. And then you're going to start with dividing by 16. So when you do long division, right, take 60 divided by 16. That's going to give you what? 3 times?
Yes.
And then you continue to do that. So once you get a quotient here, you're going to take that and divide it by 16 again, right? And then anytime that you have a remainder, make note of the remainder, and that's part of your answer. Okay.
And that'll be the last number in the
Yeah.
decimal. Okay.
Yeah, so based on the last one that we did, right? We got the first number first. It's different than the binary. So the first number first, because the 10 we got first, right?
Mhm.
Yeah.
Something else to think about. Okay.
Professor Gwen, what
Yeah.
do the X's represent?
Oh, that's just it. Sometime it would indicate like 0x like this, depending on the type of system that you use. Oops. Sometimes that just represent that this is like an address or a hexadecimal value. You would see it represented like this or this, right? And then it's also written with the lower base 16 like this. It's all the same.
Okay, thank you.
Yeah, it just indicate that it is a form of address and it is a hexadecimal value. you see this when you get like when you're trying to compile the program and you get like a memory address. Sometimes it will show up with a bunch of values. Sometimes it will have like a 0x in the front. So you know that is a memory address. It depends on the compiler. Okay. We'll see, you know, if you took my CIS-7 class before, you've seen that before. When we do recursion, sometimes it can't compute it far down the line. It just throws like an address because it says that, yeah, that's where the result would be, but it can't compute the result. Okay, so do number 4. And then I have like about 5-10 minutes left. I'm gonna do addition with you, so we would wrap up this assignment. Okay. All right. So here it talks about addition, and the way that you would do that is you can do a carry. So for example, we have 6A2. We're gonna add it with 49A. Okay. And so when we add, just keep in mind that just like what you've seen in decimal or binary, right? There gotta be times that we would do a carry. Okay. A 2 with an A is a 10. A 2 with an A is 12, and that's equivalent to a C. Okay. So when you add, you always think about what would be that hex equivalence in decimal. So A is 10, 10 plus 2 is 12, 12 is going to give you a C. Then the next 2 value, you got A plus 9. Okay, so 10 is the equivalence of A plus 9 is 19. Right?
Okay.
But 19 is larger than 16. So you are going to carry 1 over and you have 3 left. So you take that 19, subtract 16, which gives you 3 with the carry. Then that carry, we're going to add it with the left over numbers now. So 1 plus 6 is 7 plus 4 is 11, which gives you B. So this is very close to hexadecimal. The only time that you carry over is when it's larger than 16. So when you carry 1, that will be the difference from 16. Okay, let's try number 5 together. So what is 5? 1F, 3C. And we are going to add that with 7-8B2. And these are hexes, okay? Okay, so what is C? 12, right?
Right.
So 12 plus 4 or 2 is 14, right?
Uh-huh.
Which is equal to
E. Or
E. Okay, so B is 11, 12 is C, D is 13, E.
E.
Okay.
Okay.
All right, next 2 numbers, 3 plus 11, because B is 11.
Mhm.
Again, you're going to get 14, right?
Right.
So 3 plus 11 is 14, and 14 is also equal to E.
Mhm.
Okay, so now when we get to F, F is equal to 15. 15, and notice that in the past, when we looked at the example, anything above 16 is a carry. So I already know that it's a carry with the 7 because so 15 plus 8 is 23, right? So here it's actually 23. So you simply take that 23 and you subtract 16. That's going to give you a 7, right? So that means that it's going to have a 1 carry with a 7. So here, okay, so this is going to become a 7 with carry. Then 1 plus 1 is 2 plus 7 is 9. So your answer is what? 9, 7, E, and E base 16. And that's the result for the addition in hex. Piece of cake, right? So easy. Once you learn how to do it, you know. Okay, so you would do number 6 for me on your own. Okay. Anytime that's larger than 16, do a carry and then keep the difference from that carry. So take 16 subtracted. All right. Once you get a hang of it, it's really easy. All right. So if you're done with everything, save your work. You can submit it now or you can wait till later to submit it. That's fine. Just make sure that you turn it in by Sunday. Please type your name into the chat for attendance so I can have your attendance record. And that would conclude tonight. We are going to do two's complement and things on Thursday. So see you then.
Okay,
Good night.
good night.
Good night, Professor.
Question.